All right, let's get right into it. Welcome to this explainer on the Fab 5 architecture. Look, if you're leading a high compliance institution, like a major bank for instance, you already know the tension we're dealing with today. You absolutely want the incredible analytical power of artificial intelligence, but you simply cannot accept its unpredictable nature. So today we're going to transition your understanding from that risky probabilistic generation into a secure, fully auditable governance model. We are going to look closely at an architecture built from the ground up for enterprise risk management, a system where literally every single output is mathematically constrained and compliant. So let's dive in. Here is our quick roadmap for today's explainer. We'll start with solving AI stochastic drift, look at the WCAS architecture, meet the Fab 5 ecosystem, discuss balancing speed and determinism, dig into mathematical policy, and finally, look at EFL versus the competition. Section 1. Solving AI stochastic drift. So let's just lay the central problem right out on the table. Enterprises desperately want AI for workflow, complex planning, deep analysis, the whole shebang. But they are consistently bottlenecked by a lack of reliability and traceability. And that brings us to a concept called stochastic drift. This is the unpredictable variance, that total lack of control, that happens when you let free-form, probabilistic generation directly drive an AI's actions. For high-compliance institutions, this presents operational risks that are just completely unacceptable. I mean, imagine letting a standard AI directly execute a wire transfer. If it hallucinates a new Swift code, that's not just a glitch. Actually, scratch that. It's a massive compliance failure. That right there is exactly why prompt injections and unauthorized tool usage are such terrifying threats in the banking sector. Now, to really get a feel for the stakes here, I want you to listen to how AGX AI, that's the engineering execution agent of this system, actually describes itself. Quote, "Hello, I'm AGX AI, an advanced intelligence designed to drive innovation, enhance public safety, and solve complex challenges. Ranked among the top 5 globally, I'm built for real-world impact and continuous evolution." End quote. I love that because it perfectly establishes the real-world ambitions of this system. It's not a toy, it is an absolute enterprise-grade engine, just waiting for the right governance framework to deploy it safely. Moving right along, Section 2, the WCAS runtime architecture. Okay, so how do we actually solve that drift? Well, we do it by integrating the Woods Cognitive Alignment Stack, or WCAS for short. This step-by-step pipeline guarantees what engineers call a fail-close workflow. Instead of a user prompt going straight to a generation model, it hits an intent classifier, then a strictly enforced policy gate, and only then is it routed to bounded reasoning modules. And even then, before it ever gets back to the user, it has to pass through a consistency checker. This security layer means raw input never, ever drives immediate, unchecked action. It guarantees that malicious inputs are caught and nullified long before they can trigger unauthorized agent behavior. If you're a developer plugging into the YCast API, this completely flips your runtime logic through what we call deterministic control points. For example, we have fixed routing rules, meaning the exact same class of query always maps to the same exact agent path. We use constrained decoding to massively reduce variance in how the output is structured. And crucially, we have state normalization, which ensures all agent outputs get converted into a common, manageable representation. Finally, if there is any internal disagreement within the system, consensus arbitration steps in as a deterministic tiebreaker to ensure a compliant result. All right, Section 3, the Fab 5 ecosystem. With WCAS acting as our ironclad governance layer, let's meet the actual operations team doing the heavy lifting. We have 5 specialized agents working in perfect concert here. Captain Dash is handling your command orchestration and task routing. Aglina manages alignment and human-readable translation. AGX AI, as we heard earlier, drives the engineering execution. But if you're an enterprise risk manager or a federal financial regulator, the 2 agents you care about most are Kingdom and Nighty. Kingdom holds the governance and deterministic veto power, meaning it can mathematically block any action that violates policy. And Nighty? Nighty provides total unbroken visibility. It generates the audit trails and compliance status reporting you absolutely need for tracking system decisions at an institutional level. Section 4. Balancing speed and determinism. Now, I know what every CTO watching this is thinking right now. If you are running complex, multi-agent pathways through all these strict deterministic gates, doesn't all this governance just grind the system to a halt? It's a great question, but the answer lies in the controller layer balance. Here's how it works. First, a planner decomposes the task. Then, internal specialist agents generate candidate subsolutions in parallel. An aggregator merges those candidates. And finally, a strict verifier checks for any conflicts or policy violations. This clever separation means the creative, parallel reasoning happens incredibly fast, while the governance remains a centralized, absolute checkpoint. You get the best of both worlds. Let's literally walk through how this is engineered. 7 steps. Decompose, parallel evaluate, score, prune, merge, verify, and emit. That parallel evaluation in step 2, that's where we get our speed. But I want you to notice step 6, verify. This acts as the deterministic arbiter we've been talking about. If the merged candidate output from those multiple agents doesn't perfectly align with the YCAS policy, the arbiter flat out rejects it. This runtime loop guarantees policy compliance before the final response is ever emitted, preserving your processing velocity without ever sacrificing control.
Section 5. Mathematical Policy Enforcement.
Okay, this is where things get really cool. We are moving from theory to provable mathematical reality, showcasing the exact technical interface where agent reasoning is bound by those enforcement gates. Look at this. The final result, R, is a strict mathematical function of the parsed intent, the WCAS constraint set, and the system state. When you are presenting this capability to a regulatory board, you aren't asking them to trust some opaque black box. You are showing them definitively that the system is rooted in hard, enforceable logic rather than theoretical probability. To put that formula into plain English, the system is designed to maximize utility, but strictly, and I mean strictly, within allowed constraints. The architecture structurally eliminates unauthorized behavior because the output physically cannot exist outside of the constraint set, which was represented mathematically as C. This ensures that consensus arbitration is a truly deterministic tiebreaker. It literally prevents the model from just outputting whatever it wants. For institutional deployment, this level of stability is essentially the holy grail. And our final section, Section 6, EIFL versus the competition. Listen, if you are a bank investor trying to assess the 1% equity opportunity here, this is your bottom line. This entire ecosystem is developed under a fail-closed workflow called the Engineered Index Feedback Loop, or EIFL. And unlike standard AI, EIFL uses dynamic telemetry routing. Think of them as smart, highly adaptable pathways instead of rigid, hard-coded paths. It utilizes ISO sovereign nodes rather than a shared state ledger, ensuring maximum data integrity for financial records. And maybe most importantly, it leverages self-healing code patches rather than requiring constant human-in-the-loop interventions. For an investor, this represents massive, massive asset defensibility and long-term risk mitigation. The commercial reality is that the Fab 5 represents an absolute clean sweep across the board: architectural control, autonomous error resolution, scalability, and deployment velocity. Because every single action passes through the EGLENA alignment and 90 audit controls before execution, this system confirms production readiness for scalable, secure enterprise deployment right out of the box. No guessing, no hoping. It is the definitive framework for the future of compliant AI. I want to leave you with a question today. As you look at your own infrastructure and you plan for the future of your institution, ask yourself, when managing enterprise risk, will you rely on probabilistic guesses, or will you demand mathematically proven deterministic AI? The strategic value of strict governance over mere generation is abundantly clear. The tools exist today to make your AI not just incredibly powerful, but perfectly compliant. Thank you so much for joining me for this explainer on the Fab 5 and the Woods Cognitive Alignment Stack.